Okay, so I just want to express that uh, none of what I'm talking about here uh, will is related to ethanol distillation, which is illegal where I'm at. That is not the purpose of this video. The purpose of this video is simply to explore how you could produce or create your own distillation apparatus at home relatively cheaply and be able to, say, distill your own water, or maybe you want to just do chemistry. Um, Maybe even, yeah, it's just, purify water or something like that and get distilled water. Um, Now, the basic construction of a still, um, well, distillation is a process for separating liquids of different boiling points. So if I have isopropyl alcohol and water in a mixture, because isopropyl alcohol boils at a lower point, I can set my heater to just above that point, and then all or most of the, it might pull some water with it, but you will get a separation. I think of two curves overlapping, and here's the isopropyl curve, here's the water curve, and if I cut down the middle, I'll get some water, but I'll get the bulk of the isopropyl out, and this is a way to purify compounds. Distillation is a technique that has been used, I think, for thousands of years. I don't know the history, and I actually do want to look into the history, but um, I've been doing some research on how to build my own because it seems like a really interesting project and a fun challenge. Now, uh, it seems like what most people do, and what I chose to do, is to build it out of copper pipe. Now, there are some advantages to copper pipe. The downside is that it's moderately expensive. Copper is a pretty expensive metal relatively, but it's pretty workable in terms of machining it or whatever. It has a good thermal conductivity, and there's one more. Oh, well, it has this property that it can pull sulfides out of the liquid. I don't actually know the mechanism by which that happens, but I've read that. So I'm just conveying stuff that I don't even know about. So this just downgrades the validity of everything I'm saying because I don't even know what I'm talking about. But I just wanted to talk about, because now Red has a great video on how to build a still, but I actually think it's not a great video because he leaves out a lot. And I think he did it intentionally, but there was a bunch of frustrating things that were kind of interesting to learn about. Uh, but I'm probably going to set up my camera and actually do some drawings um, so that you guys can get a look. Because I haven't set this up in a while. And I feel like it'd be kind of fun. I have like 2 hours. I think that's enough time. But I just want to start to get into... actually, let me just get the camera. All right, I haven't done this in a while, so we're going to see how this goes. Okay, I'll probably need to get some electrical tape, but let's get this thing set up. All right, let's see if we're good. Okay, good. All right, so now I just gotta get some electrical tape. Actually, maybe this will be good. Let's get this out of the way. All right, I think that that's good. I just gotta plug in the computer. Actually, let's see if I can get this to be nice and. Okay, now I just gotta flip it so that when I say this isn't even the right note. If I say hello, I need to, and I'll probably need to get the tape. Why is it so dark? It's so dark. Okay, now we just need to do. Wait, test? Okay. Transform. Okay, so all right. So here's what I wanted to show. So the basic operation of a still, I mean, actually, a lot of people don't even have all of these parts, but you're gonna have a boiler. So let's start with a boiler. Okay, so this is going to be the boiler. Then this is going to be an induction stove. Okay, it's going to heat up the boiler. Now the boiler is going to have a hole in it, and we're going to get into the junctions later, but the idea is that a pipe is going to stick out of this thing. Okay, and what's going to happen is as this liquid turns into vapor because of the heat, the vapor will travel up here, and what we're actually going to do is we're going to put a copper wool in it to impede the flow of travel. And this is going to go up to a T-junction. Okay. And I'll get into sizings and dimensions later. But this is going to be the general. This is going to be the precursor. This is going to be the, quick and dirty explanation of how to build this thing. How do I just brighten up the image? I don't know how to do that. It's too dark. How do I How do I change the ISO? Okay, that seems pretty good to me. That seems better than it was before. I don't know. It's very hard to say. Okay. So this will be a T. So we're going to call this T. Actually, I'm not even going to get into these parts. I don't know why I did that. Then we're going to have a little piece of pipe here. And this little pipe is going to connect to another little piece. And this piece is going to connect to a thermo well. Okay, so what that is a thermometer. Thermometer. Then we're going to have a pipe that comes across here into a bend. And I shouldn't actually even be talking right now because I'm not convinced that this design works. And until I build it, I don't know what's going on. Then we're going to have a pipe that comes down here. And around this pipe is going to be another pipe. So we're going to have this reducer part. And this reducer part allows us to put another pipe coaxial into this. And then it's going to come back down. Or it's going to, it's actually going to look like this. And then this goes like that. That's not exactly right, but that's kind of right. So then what we're going to do is we're going to have just a 45-degree angle part. And then we'll collect here. And what's going to happen is we're going to drill holes into here, and we're going to try to solder little barbs onto here that I can attach a tube. And this tube will go to, a pump. And so this is the basic idea. But now I want to switch over to the webcam and show some of the parts. Actually, wait, let's do this. I kind of like this. All right, so I have this big bag of parts here. All right. Now, this is kind of a kit for doing... So, one thing to know about this is that copper pipes are used in residential plumbing pretty ubiquitously. And the sizings here in America that are typically used in residential plumbing is 1/2 inch and 1/4 inch. And I have a big gripe with these nominal sizes. So when you buy lumber, they say, okay, it's a 2x4. Yeah, but then you go to measure the 2x4 and it's not even close. It's usually like a 1/2 inch under. And I don't know. I thought the reason for that was because it shrunk, but apparently I don't know if that's true or not. But in copper pipes here, you would think that A, since we are manufacturing this metal, we can get as tight a tolerance really as we want on these parts. So if we call this a 1/2 inch, either the outer diameter or the inner diameter should be a 1/2 inch. Now that's actually not true, and the dimensions of this thing basically are not even related besides a general guideline when they say this is, this is a 3/4 inch to 1/2 inch copper fitting reducer. Neither of these dimensions are a 1/4 inch or a 1/2 inch or anything close to that, outer, inner, whatever. So just goes to show, you know, there's lunacy in this because it's totally insane. Okay, but anyways, let's just keep going. So here I have a kit for so this is also another interesting tidbit that if you want to build one of these, you'll run into. They say that you need to use silver solder, and you look at the cost of silver solder, and it's really high. And you're like, oh well, because it's made of silver. But actually, most of these silver lead-free solders are like 2% silver. So why is it so expensive? I don't know. Someone let me know. But in any case, they always use this stuff, and they use flux, and you put on the flux and whatever. And I'll get to that later today, hopefully. But for right now, we're gonna move on because I really just mainly want to talk about fittings. And so, right now, the next step is we're gonna zoom in on this area. Okay, so this is I'm gonna call part A. I want to focus this as B. This elbow is pretty simple, so I'm just going to lump it in, and we're just going to call this part C. Okay, so let's just look at A. So in A, we're going to have a hopefully flat plate. Okay, so I'm going to draw a flat plate like this. And now this is the boiler top. And what we're going to do is we are going to take, and I'm not convinced that this is a very good design, but I am kind of just copying Nile Red at this point. But I think that it will work. It's just a little bit weird. So what we're going to do is take this part, which is known as a 3/4 inch. Okay, so actually I want to preface with some extra information. So there are two main joint types. So I mean, in lots of mechanical assemblies and all sorts of things, you basically are taking the atoms, the constituent simple parts, and you're putting them together to make something specific. And it's the same in programming, whatever, electronics. I don't know. In this plumbing stuff, there are two main joint types that you come across. There are soldered joints, and you'll see these called sweat joints. I don't know the name, reason behind the name, but I do know that they are called sweat joints. So on this side, let's see, can we get a good picture of this? This side is a sweat side. Okay, then the other joint type is going to be NPT for National Pipe Thread. Okay, so that's just kind of did auto make it darker? Let's see if I do this. That's good. So that's great. But now when you're joining things together, typically you have mating parts. So like let's see, what's a good example? I actually don't have any demo pieces here. Let me go grab a little demo piece. Okay, good. So I brought some copper pipe, just a test piece to show you guys some stuff. And then I also brought calipers. And let's see if you'll get the reading on here. Probably not. Maybe if I angle it. But I just want to take a pipe. So this is called 3/4 inch copper pipe. I'm going to measure the OD, 870 thou. Okay, whatever. I'm going to measure the ID, 800. Okay, so neither of those are 3/4. So that just goes to show that these guys, they make no sense. There is something I wanted to say. Oh yeah. Also, typically, when you're buying pipe, well, you know, okay. If you have a hollow cylinder, there's really 3 main parameters, ignoring length. There is the outer diameter and the inner diameter. Those are actually the main 2. But the combination of those gives you wall thickness. And there are 3 classes that I've seen of wall thickness when selling copper pipe. There's type M, which is the thinnest, I think, and the cheapest. Then type L is the thickest. And I think K is in the middle. Now, if you're building a condenser, Liebig condenser, basically this jacket here, you want the inner pipe to be as thin as possible so that the water is as close to the hot vapor as possible. I think I got type M for both, and it should work out fine. Okay, but here, I want to make a little matrix to explain basically joints in plumbing. So we have the male side, and we have the female side. Then we have sweat and NPT. And this is just like a buyer's guide. This just helps you understand, what am I actually buying? Because, you know, you got to call this thing something. And when you go to the hardware store, yesterday, the guy only spoke Spanish. And I was like, you know, and I speak a little Spanish, but not enough to talk about copper pipe, you know, joinery. Anyways, it turns out that the male sweat is called a street. So if you have a male, let's see, do I have a... I actually don't think I have any street. I don't think I bought any street. But if, for example, let's see, okay, let's just pretend that this side is a street. It's just a piece of, oh, actually, okay, you could consider the diameter of just normal pipe is to be a street, and that means that it goes inside the female side of a sweat joint. So the female side of a sweat joint is usually called a cup. And now and so, you know, what you would call this then, well, okay, let's finish the matrix and then I'll explain. So now for pipe, male side of a pipe is called MPT or MIPT. And what this stands for is male pipe thread. Very creative. Or male iron pipe thread. This I stands for iron. And I believe that they're the same. Now, you can probably figure out what the other one is. It's just going to be FPT or FIPT. Okay, great. So now we can start to name our parts. So this is going to be a 3/4 cup, and I believe that this inside is actually a 1/2. So it's going to be a 3/4 cup to 1/2 FPT, because these are internal threads, and so it's going to accept outer threads. The internal threads, so I could actually say these are internal. And these are external. Okay, so now we know how to name our joints. So now for the rest of the video, I can start to talk about these in a more precise way. Okay, so we are now going to go back to part A, where we have our boiler top. So the design that Niall Red used, and I'm basically copying from, and this is probably the part that makes the least sense to me. The rest of the video makes a lot of sense, but this part is kind of confusing, and I thought I could do it another way. But let me first explain the way that he does it. Okay, so actually I can just arrange these together kind of in the spots that I want. So this is the way that it's going to go. Oh, and one thing to know is that National Pipe Thread, NPT, is tapered. So these threads actually get smaller as you go down. It's really important to know that. Okay, so this is basically... Let's see, will I be able to get this in here? Here we go. Okay, so this is basically how this is going to go. So we're going to have our boiler top sitting right below the hex. They call it a flange. This hex lip or flange that connects the cup to the MPT. Remember, now we know that this is external threads. It's male pipe thread. And so then basically this whole apparatus is going to rest on the fact that, because there's no threads under here, so I'm not going to connect this. And I'll talk about what I thought I could do and why I chose to go this route. And so basically what the whole weight of the still is then going to rest on this thing resting on the boiler top. Okay, so let's start to draw that. So I'm going to have it's going to look like this. Okay. And it's going to come in. All right, so this part is part 1, which is a 3/4 cup to 3/4 MPT, male pipe thread. Okay, so that's the first part. And now, so the mechanical, the load is going to be on that lip. Now what we're going to do is place part 2. Okay, so this is part 2. Now part 2 is a 3/4 FPT to 3/4 cup. And remember, cup is the female sweat joint name. Then finally, we are going to have part 3, which is the 3/4 inch. Actually, let's put the inch on all of this. The 3/4 inch type M copper pipe. And I purchased 5 feet for this build. I'll give the total cost breakdown probably in a subsequent video because I haven't actually added it all up. Luckily, I already happen to have the silver solder stuff, but it was looking like that was going to be an additional $40 on top of the whole assembly. I think so far, excluding the boiler and excluding the stove, all of the copper pieces was about $90, and then the thermo well, I got a 2-pack of the thermo well, excluding the actual sensor and thermocouple, or amplifier, or whatever you want to call it. Just the thermo well itself, the thing with the NPT threads on it, was a 2-pack for $14 on Amazon. So roughly all of the copper and all of the assembly part of this, excluding pipe cutter, your flux, solder, all that stuff, it was about probably $105. And the boiler will probably be an additional $40 to $50, I think. But okay, so we have part A's assembly down. Right, so let's block out this. Let's block out this. Okay, so that is the drawing of this. So we got the 3/4 cup to 3/4 MPT. MPT. Then we got the 3/4 FPT to the 3/4 cup. And then we have a 3/4 pipe. Okay, now it's time to go on to part B, which is the T. Okay, so let's draw the T. Okay, so this is the T, so I'll just call this part 4. Part 4. Actually, I shouldn't have done it like there. So what this is called is, it's a three-way junction, so you basically name them based on the sizing. And so typically a T is always a cup, is all cups. I think it's probably, they probably do make, you know, all combinations of this. But in this case, we're going to have a 3/4, 3/4, 1/2, all cup T. So what that means is that pipe will fit into here, pipe will fit into here, pipe will fit into here. No, nothing is going around these parts. So actually, here is the T. So this is what the T looks like. And here, I think this is a small cut. So this will just go directly in here. So there's no actually, I think I want to see if I can try to improve my lot in life and get this a little bit closer. Oh, is that the wrong? Oh, shoot. Okay. I wanted this guy. Okay, so now all right. Let's just zoom out a little. Oh yeah, okay, I gotta get some tape because this is gonna be a pain in the butt. All right, well, let's live with it for right now. Okay, so here is the T. So what's gonna be on both sides of the T? Well, this is incoming from, so one thing to note is vapor path. Okay, so as you can see here, the vapor is going to travel from here to here to here. It's going to turn back into liquid and then be ejected into our flask. So in here, we're just going to have normal, regular 3/4 pipe. Now in here, I didn't really leave myself enough room. Let's cut it off. Let's ignore this. Okay, so I'm going to put a short piece of pipe in here. Okay, so this is 3/4 pipe. And what I'm going to do, the reason for that, is that then around this, I have this part. So this part is going to go actually just like this. Okay, it didn't quite fit on there. I'll probably have to sand some of this stuff down. But so we have the T, the pipe, and then this part, which is a 3/4 cup to 1/2 inch FPT. Because the thermo well has a 1/2 inch MPT on it. So then we'll have, you know, this part that, so this is the pipe, this goes around, and then it goes around, and then in here we have female threads. And then in here, we're going to have The thermal well. Okay, that's the worst part of the drawing. Terrible drawing. I really was hoping to do some good drawings today, but that was terrible. This is a thermal well. So then this small short piece of pipe I'm not going to label as a part. We're just labeling all the joint parts. So this is part 5. And it's a 3/4 cup to 1/2 FPT. Okay, and then we have the thermal well. And maybe I'll link to the thermal well. Can you see that? Okay, great. So then the only thing after this is a 1/2 pipe. And we're ready to move on to part C. Now I'm going to have to turn the page. So okay. All right, no comments. All right, so what we're doing now is we're doing part C. So, okay, so part C, it comes in like this. So let's make this right. Okay, so here is 1/2 inch. So this is 1/2 inch pipe. And what we're going to do is have what's called an elbow. It's just a 90-degree part, just a bend. Okay, so this is part 6. 1/2 cup. 1/2 cup. 90-degree elbow. And remember, cup means sweat, which means you have to solder this together. Okay, now what we're going to do is we're going to have a 1/2 inch pipe going all the way down. Okay. Then what we're going to have is a part that goes like this. And it kind of comes out like this. Okay, then in there, and I'm going to name the part, but just give me a moment. Okay, so let me actually show one of the parts. So this is the part that I'm talking about. Can you see it? So on one side, you have a 1/2 inch cup. On the other side, you have a 3/4 inch cup. So this is known as a reducer. And the idea is that we're going to put the 1/2 in and we're going to put the 3/4 in. Now, it turns out that there's these little bumps. There are these little bumps that they put on the inside to prevent the 1/2 from just going all the way through. We're going to have to file that down to get rid of that so that we can push it all the way through. I don't think that will be much of an issue, though. But it is definitely something that you have to do. So then that's going to sit here like this. And then we're going to have, the 1/2 inch pipe and then this. So, okay, so let's name this. So now that we know what this is a 1/2 inch cup to 3/4 cup reducer. I get burned or something? How did I cut myself? Okay, so and then this is just 1/2 inch pipe. So this is part 7. I think I got okay, and then this is 3/4 pipe. And the idea here is now we're going to drill a hole. We're going to drill a hole and we're going to try to solder probably just to the very edge of this because I don't want to disturb the flow of water. I want the flow of water to be relatively high for better heat conduction. Because the whole point of this jacket, and I didn't buy these, so I'm kind of just messing around. I just had these lying around. So these are called barbs. And even though it's threaded, we are just going to solder. And so a hose will go over this. Okay, now what we're going to have is another one of these reducers. Okay. So now we've reduced it down, and then we have a 1/2 inch coming out. So now by this point, we should have liquid, and here we have gas. So vapor, liquid. Okay, so this is part 8. Same as 7. And then all we're gonna do is just to get it a little bit farther away from the stove. By the way, I'm specifically going to be using an induction stove because I'd rather not expose anything to open flame. I think that that's probably a dumb idea. Okay, now this is part 9. And it's a 1/2 cup, 1/2 cup, 45 degree, or really 135, but they probably call it 45 elbow. And then we just have a little bit of pipe, and that's it. Then we have the beaker. So that is the design. We have designed a still in 45 minutes, and most of that was just setting up. So I think I'm just going to end the stream and then get to actually trying to build this thing, because I don't think that there's much else to explain about doing this that I can show on drawings.